In this presentation, we will learn how to allocate memory dynamically using malloc function. So let's get started. What is malloc? Malloc is a built-in function declared in the header file stdlib.h. It is a built-in function declared in this header file stdlib.h. Okay. Malloc is the short name for memory allocation and is used to dynamically allocate a single large block of contiguous memory according to the size specified. So you specify some size in the malloc and it will allocate a single large block of contiguous memory. So syntax of malloc is clear that malloc requires a size and it will return a pointer, basically a void pointer. Malloc function simply allocates a memory block according to the size specified. Here you can see the size needs to be specified and malloc will allocate a memory block according to the size specified. And on success it returns a pointer pointing to the first byte of the allocated memory. Else it returns null. As simple as that. On success it returns a void pointer. If it fails somehow, then it will return null. So the job of malloc is to allocate memory at runtime, and that must be clear to you. Apart from this, you should understand that size t, which I have specified over here, is defined in stdlib.h as unsigned integer. This I have already told you in the C programming lectures, but I am specifying here it once again that size t is nothing but an unsigned integer, the largest unsigned integer possible. Okay. Here size t's size means you should specify the size in an unsigned integer form. Obviously the size cannot be negative, right? So it should be an unsigned integer. Now here you can see the pictorial representation of a heap memory. Just an imagination, and here some contiguous block of memory has been allocated by malloc, and malloc will return a pointer which is basically a void pointer. We are assuming that this pointer is ptr, so ptr is the pointer which is pointing to this particular memory. Now, why malloc returns void pointer? Malloc doesn't have an idea of what it is pointing to, let me tell you that. Malloc simply allocates memory for us. It doesn't have an idea of what it is pointing to. It simply means that it doesn't have an idea about what data will be stored in that memory location. It merely allocates memory requested by the user without knowing the type of the data to be stored inside the memory. So it doesn't know the type of the data at all. That is why it is returning a void pointer. It simply allocates memory for us without even knowing the type of data to be stored inside the memory. How it will know the size beforehand? We just want malloc to allocate some memory for us. After that, it is our responsibility to typecast it to an appropriate type so that we will use it in our program properly. Void pointer is a pointer which can point to any type of data. Malloc returns that void pointer because it doesn't know which type of data will get stored inside that memory. Here you can clearly see that we are asking malloc to allocate 4 bytes of memory. Here if you are specifying 4, it means that we want the malloc to allocate 4 bytes of memory. Now with this, malloc will return a void pointer if it is a success. In that case, we need to typecast it to an integer type of pointer because we want to store an integer within that memory location. Malloc simply allocates 4 bytes of memory and it will return a void pointer. We will typecast it to an appropriate type, and then after that we will store that address within some pointer of our choice. As simple as that. Here we are typecasting the pointer. We want to store an integer. That's why we have typecasted it to an integer pointer. After that we will store the address returned by the malloc in this ptr pointer. It could be any name, doesn't matter. But here my choice is ptr. Malloc allocates 4 bytes of memory in the heap and the address of the first byte is stored in the pointer ptr. As simple as that. So the address of the first byte is returned by malloc and that will get stored within this ptr pointer. From there we can access the rest of the bytes. Here is a simple example program I want to show in order to understand the concept of malloc in a proper way. Here you can see with the printf function I am asking the user to enter the number of integers. We have declared 2 variables over here, one is I and one is n. N is the place where we will store the number entered by the user. Here we are asking the user to enter the number of integers. We'll store that value within this n variable using this scanf function. After that we have a malloc function. What we are doing here is we want the malloc to allocate the size equivalent to the size of n integers. That's why I have put here n into size of integer. Why size of int? We don't know what is the size of integer in our computer. That's why we are using the size of operator. With this, we will multiply this with n. This will give us the size of n integers. We are asking the malloc to allocate memory for n number of integers. After that, obviously malloc will return a void pointer and we are typecasting it to an integer pointer and we are storing the address within this ptr pointer. Typecasting is important. You should do the typecasting. It's a good practice. Okay. If pointer contains null, then it means that memory is not available. So we'll simply exit out of the program with the exit failure status, right? If this is not the case, then we can easily run the for loop from 0 to n-1 and we will ask the user to enter an integer one by one. So here in this case, obviously this loop runs from 0 to n-1. We are asking the user to enter an integer every time. Now here you can clearly see within this scanf function, there is one thing written over here, ptr plus I. What does it really mean? We know that ptr contains the address of the first byte of the memory. Let's say that address is 1000. Here I is equals to 0 initially, so this is 1000 plus 0, which is 1000. So within that address, our first integer will get stored. Then after that, when I becomes 1, here this becomes 1000 plus 1, which has internally been interpreted as 1000 plus 1 into 4. If I'm assuming that size of integer is 4 bytes, then obviously this will be 1000 plus 1 into 4. This we have already learned in our C programming lectures. If you have any problem in understanding this concept, it is better to see C programming lectures created by us. Here you can see this is ptr plus I. If I is equals to 1, then this will be 1000 plus 1, which is interpreted as 1000 plus 1 into 4, which is equal to 1004. So the next integer will get stored in 1004 location, and this will continue in this way. So the addresses are like 1000, 1004, 1008 and so on. And let me tell you why we are not using ampersand over here. Here we need ampersand because n is representing the value. We need the address. Scanf requires the address. That is why we have to put ampersand over here. But ptr is already giving us the address. When we simply write ptr, which is a pointer, pointer contains the address and not the value. That's why there is no requirement of putting an ampersand in front of it. So this concept needs to be clear. After that, we have a for loop again, where we are simply doing one thing. We simply want to print all the integers on the screen. Obviously, we're using ptr plus I, but here in this case, we are dereferencing it. Because this represents an address, we need to dereference it. If I is equals to 0, this will be 1000 because we are assuming the first address is 1000. So we are dereferencing it, then we'll get the first integer. With this, when I equals to 1, then this will be 1000 plus 1, which is interpreted as 1000 plus 1 into 4. If size of integer is 4, then this will give us 1004. We are dereferencing it, so this will give us the second integer. In this way, everything works. So basically, this is a simple program which is asking user to enter n integers, and then we are simply displaying those integers on screen. Let's execute the code in our favorite IDE. Now you can clearly see the program is available in front of you. Let's execute this code. It is asking us to enter the number of integers. Let's say we want 3 integers to be entered. Let's enter one integer. Let's say it is 43. Let's enter the second integer. It's 56. Let's say it is 78. Now it is displaying all the integers on the screen. That's what we want, right? First, we are asking the user to enter the number of integers. Then after that, the user is entering the integers. And then we are simply displaying them on the screen. 43, 56, 78 will get printed on the screen. Okay friends, this is it for now. Thank you for watching this presentation.